Okay, let's give a explanation here for essential question number 2, version 10 in the fall of 2011. So let's go ahead and take a look at our sequence and what's actually shaped like. What it looks like is we got a sequence, a constant sequence over here, -1, constant sequence over here that's 4, and then you know that hanging off of it is going to be something that looks like a linear gradient. And here's what's funny about the linear gradient. See, it goes 1, 1, 1, down by 1, down by 1, down by 1, and then it goes down by 2. So what we have to do is split this thing up. So we'll put a constant sequence over here. We'll get another constant sequence and break things there. And I think that should probably do the trick for us. So the way that we're going to arrange this is that we'll do the constant series that goes all the way across, and then we'll drop a linear gradient down here. And then, here's where it gets a little bit worse than that, is we have to build a constant series. Let's see, we'll do it right here. And we'll drop another linear gradient on top of that. So this is kind of a complicated one. So let's move this guy out of the way and give us some room to write. And so let's get ourselves something which is a little easier to work with. There we go. So we're looking for present worth. And the first constant series is -1. So we're looking for P given that we know A. Here's the interest rate, and it was 3 long. We're going to have to do some time shifting, so I'll put that underneath. The second section that we had, which was right up here, well, I'll deal with this constant series first, is something which is 4 high. So we're looking for P, given that we know A. Here's the interest rate, and let's count them. There was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those. So I'll go ahead and pop a 10 there. And I know that we're going to have to do some time shifting, so I'll put that underneath. And then over here we also have a linear gradient. And so that's the one that goes down by 1 each time. So looking for P, given that we know G, here's the I. Let's do some counting now. So there's 1, 2, 3, 4, 5, 6, and we add 1 for the pot. So we go ahead and stick a 7 in there. So we'll do that 1 plus I. And now let's get the last segment over here. So there's a constant series that's -4 tall. So we'll put a -4 in there. P, given that we know A, here's the I, and it's 3 wide. 1 plus I. And then this is like one of the smallest linear gradient series that we'd ever seen. So you know what I'm going to do? Let's do it anyway. So let's go ahead and do a -2. Looking for P, given that we know G, I, and because we have only 2 elements, we have to put a 3 here. Divide by our 1 plus I to the something. So let's go ahead and get all our time shifting done here. So for this one, the very first one, that constant series that's right here, this should clearly have a -1 that's right there. 3 plus -1 gives us 2, and 2 is the last time period where we actually see a -1, so that one's fairly easy. The constant series that is 10 long, so this one over here, if you notice last time you see it's in time period 12, that means that we need to put a 2 there because 10 plus 2 is equal to 12, and the n and the exponent are supposed to add to the last time period we actually see the value. Now it's time to deal with the time shift and linear gradient series. This one also ends in time period 12, so clearly we need to have a 5 there because 5 and 7 gives us 12. The sequence of -4s, let's see, let's take this one another way. Let's see, if this right here is the constant series, that means this one right next to it is where the 0 is, and that's got to be time period 12. So we'll put a 12 there, and if you see our counting rule works too. 3 plus 12 is 15, and 15 is the last time period when you see an element of that. And then finally we have this little brief linear gradient, and if the last time we see it is time period 15, we should go ahead and put a 12 here as the time shift part, because 12 and 13 is equal to 15. Easy. And if you want to examine this a little bit more, the first time you see an element of the linear gradient. It should be time period 2, so that's 1, so that should be the 0, and sure enough, that's time period 12. So there's your explanation to essential question number 2, version 10, in the fall of 2011.